kick off. Good morning, good afternoon, good evening. Very warm welcome to our Ask Me Anything session. I am Jayashree Hegde. I'm super excited to have you all today. As always, we have MQTT experts from our team. Today we have on our panel Florian Raschbichler, Head of Support, and we have Jens Deters, who is Head of Professional Services, joined by Florian and Jens's Gaurav, who is the Director of Product Marketing, who will be moderating the Q&A. And before we kick off, a couple of housekeeping pointers. We will be recording this session and we will share the recording in a follow-up email. And then there are two polls running for this session, one right at the beginning, just so that we have an idea of your MQTT understanding. This will help our panelists, craft their answers according to your MQTT understanding. And then there's the second poll right at the end of the session. Then I request you all to participate in all the polls. And without further ado, I will hand it over to Gaurav. And I will start the polls. So welcome, everyone. It's great to have you all. Gaurav, over to you.
Thank you, Jayashree. Thank you.
Jayashree.
Yeah, so if you could put the poll up.
Yep.
So we're looking to get a sense of what your level of knowledge about MQTT is and your plans on using MQTT. We'll give you a couple of minutes here to pick your response.
Okay, I'll end the polls now. Thank you so much for participating.
Great, thank you, Jayashree. Okay, let's dive right in. I want to begin with this question around Sparkplug. We might have audience from different backgrounds here for everybody's benefit. Sparkplug is more to do with industrial IoT, so industrial IoT use cases essentially. So the question we have here is, they're looking for more information around the Sparkplug specification. And if those specifications are included in MQTT 5 or are they separated like with MQTT 3.1.1? This question is coming from David Vantigam, and that's all they're asking. Jens or Florian?
Well, I got this question in the way that Sparkplug is part of the certain specification. Yeah, well, it's not. The Sparkplug specification is about how to use MQTT in a way to achieve certain goals. Like, so the focus of Sparkplug is the workflow, how to implement a asset or a state management for state management for assets or devices. It defines some key principles like report by exception. It has a certain topic structure. It describes a certain topic structure, and is a specification how to implement and format the payload. But the Sparkplug specification is on top of MQTT. So it's MQTT is a communication protocol, and Sparkplug is how to use it to achieve certain goals. And it's important, the current Sparkplug specification is making use of MQTT 3.1.1, not the magic stuff coming with MQTT 5 by now.
Yeah, and maybe if you allow me to add, something here based on what I read from the question, right? So you can use Sparkplug with both MQTT 3.1.1 as well as MQTT 5. That's what that means. If it's based on 3.1.1, that means MQTT 5 will cover everything 3.1.1 has, plus more. And that means you can, with both MQTT 5 as well as 3.1.1 clients, you can implement the Sparkplug specification for payloads, topics, message flows, everything that Jens said.
Excellent.
Yes, and here's why. So the MQTT features Sparkplug is using or depending on is quality of service 0 and 1. It makes heavily use of retained messages and last will and testament. You need a broker and also a client which implements this. And yeah, basically this is defined by MQTT 3.1.1. And yeah, that's why you have to use at least 3.1.1.
Makes sense. Thank you. And a resource I would love to point out here is a blog post series and a set of videos we have done late in 2020 around Sparkplug. We have the MQTT Sparkplug Essentials ebook. And thank you, Jayshree, for directing people to that resource. All right, thank you for that answer, Jens and Florian. Next, we have, in fact, several questions on OPC UA. So there's great interest in OPC UA, and I'm sure there's some myth busting also we'll have to do here because we can see people referencing to OPC UA as a protocol in some of these questions. So the first one I'll pick here is from Frey Patrick from Endres Hauser. And Frey is asking, is MQTT able to interact with OPC UA server? And the example they have in mind is, say, an MQTT broker or a client publishing into an OPC UA node, which is part of an OPC UA deployment, and also the inverse. Can an OPC UA client publish and connect to an MQTT subscriber? I think some of the terminology may not be 100% accurate here, but largely they're talking about MQTT client and broker interacting with an OPC UA infrastructure. So let me start with you, Jens. What are your thoughts on this?
So basically, yes, it can interact. You can bridge between the two worlds. So OPCUA architecture and PubSub architecture using, for instance, MQTT. But this needs some implementation. So you have to implement or purchase a gateway which does the bridging for you. So OPCUA basically depends on, or it is based, the architecture is based on request response pattern. So there's a client server connection and relation. So all the data in OPCUA environment is provided by a server and clients are requesting data from the server. In the PubSub environment, you will get notified if there is something for you. So it's a push mechanism. So it's a really different pattern and a really different architecture. So to use the best of both worlds, you have to have a gateway or implement a gateway to handle the data flow. How to do this is specified by the OPC UA specification part 14. I think this is the PubSub specification. But this is not about there is a PubSub extension for OPC UA. It's about how to deal with the OPC UA data format in terms of using a PubSub protocol. The part 14 specification recommends using AMQP or MQTT as the PubSub protocol here. So yeah, again, the OPC UA PubSub is all about how to deal with the data format OPC UA describes.
Makes sense. Anything you want to add, Florian?
Not really. I think Jens covered it all too well. My biased follow-up question to the question would be why, right? So certainly, from a messaging point of view, the PubSub push communication is superior to a request response. Right. So I would want to go there, but of course I understand in the reality there's legacy systems, there is existing brownfield deployments where you just don't have the choice of replacing everything. So and for these cases, like Jens said, you can basically maybe not get the best of both worlds, but bring both worlds together by either implementing this by yourself, or also, as mentioned, there are some vendors out there that offer pre-built solutions to basically translate between request response and PubSub.
If you want to play with this, and you are familiar with Node-RED, there are really interesting nodes you can use to deal with OPC UA infrastructure and connections, and to combine or to bind it or transfer it into the MQTT world. So if you would like to get an impression, how a really easy impression, because it's low code using Node-RED, this might be a good starting point for that, to get a feeling how to deal with it, how to use it.
Right, and the other sort of element to consider here, Jens, is around the fact that OPC UA, it appears like a closed club, right? There are only specific number of vendors who continue to focus on this. Yeah.
If this question goes in the direction to implement an industrial IoT infrastructure, OPC UA is not the answer to industrial IoT. So to implement industrial IoT, you have to really go the hard way and to implement a very new architecture system in parallel. Industrial IoT needs to be, first of all, it needs to be open. It needs to be an open standard, it needs to make use of open standards, really open. So OPC UA is not open. It's a closed shop. It's a pay-to-play thing. So you have to be a member of the OPC Foundation, and then you are free to implement the OPC UA. I think it's way more than 1,000 pages. All these standards and specifications in OPC UA. But you only have to access to this documentation when being part of the OPC Foundation. So it's not open. And which MQTT is, for instance. MQTT is a really open source protocol, an open standard and specification. In an IIoT environment, one really fundamental target is to be lightweight, which OPC UA is not at all. It's HTTP SOAP, so heavyweight communication structure with client-server relation, and huge data format specification. So it's in comparison with the payload format of MQTT and all the lightweight communication protocol. It's OPC UA is not lightweight at all, and you need a kind of a report by exception principle. So as a data consumer, you just want to be notified if there is new information for you. If a sensor value has not changed during the last hour, you don't want to be notified every 30 seconds that there is no change or with the same value. You just only want to be notified on a data change, and this can be achieved also with the PubSub approach, with a PubSub pattern. So just to notify all subscribers that there's new data by a push, and not forcing all clients permanently to pull the data. And OPC UA is not supporting this in a good way.
Makes sense.
That's
Thank you,
why
Jens.
OPCUA is cannot be used to achieve the industrial IoT goals.
Thank you. All right. So the next one here we have is around timestamps. And this question is by Svetozar Yolo. And Svetozar, I think he's also on the call. So let's read this question, get our initial take on it. And if Svetozar would love to, or rather prefer to do a follow-up, we will make sure that we unmute Svetozar. So what we are saying is that in case of the requirement of timestamps, is there an approach, a recommended approach? And the use cases in applications where DNP3 is applicable, can we use MQTT as a replacement, which is where timestamp becomes critical, and especially when the client is in a persistent session. So what are your thoughts on timestamp and keeping that integrity of timestamp? Yeah,
certainly. So first of all, what did you say? Did you say DNP3?
DNP3, yeah.
So I'm not familiar what that is.
It's a distributed network protocol, which is used for also.
So what's the requirement here? Because if you want to get the original timestamp from a message as it was sent by a sender, I would say immediately there's two ways to go about it, right? If you're using the more known but older version of MQTT, which is version 3.1.1, but it's commonly referred to as MQTT version 3, then you can add this timestamp within the payload. We've seen from some of our customers here, for example, what's very, very popular here is basically that you have something which is called a data envelope, right? So you have some type of key value based data structure, such as JSON, or more popular these days is something like protobuf, which is you can save data by using a compressed structure like protobuf, and then you have basically one key timestamp, and you have the timestamp value, and then you have a second key that's like payload, and then you put the actual payload there, and this way you can correlate with MQTT version 3 the timestamp with the payload. With MQTT5, it's even much I would say easier or more elegant ways of solving this by the introduction of the so-called user properties. Just a quick reminder for those here that might not be extremely familiar with the MQTT5 specification. What the user properties are is a key value string pair that can be added to almost all MQTT packets. So very similar to what headers are in HTTP. And this is specifically designed for use cases like this, right? So you do not have to go into the payload of the published packet and put information there, but you can actually put an envelope around the whole published packet and then put the information there with the timestamp. And then, of course, typically the Unix time of the time the message was sent, the publisher can set this, and then the broker will automatically forward this timestamp to the receiver, and the receiver can even read the timestamp without having to go into the published packet and actually unpacking the whole payload. This is the added benefit here between using a payload versus user properties. If you want to go super technical, the payload is technically a byte stream, whereas the user properties, they're already ready to read a string pairs. It's already UTF-8.
Sounds good. Anything to add, Jens?
No.
I mean,
you should just avoid skipping the payload for as a data layer, and put any information into the user properties, because technically that is possible, but should not be the right way.
Yeah.
So
that's correct. But Svetlana, does this answer your question, or do you have a follow-up?
Yes, thank you, sir. I'm asking this question because in nowadays there is a lot of system, especially in water industry, which rely on this protocol DMP3, which got some features. For example, something similar for persistent session, which MQTT got. So my idea is to replace in some of our project such solution with MQTT, but in this solution where you have to send data information with timestamp of the sender, that is why I'm not persistent, but looking for a solution using MQTT and making the timestamp of the publisher to be available for the application, which is actually subscriber. Thank you.
Thanks.
What you can do as a proposal for a specified payload format, also depending on the timestamp, you might have a look at the Sparkplug specification, because then you have a specified way how to format the payload. So basically, it's a JSON object, and then you have a defined structure for your payload.
I see. Well, as far as I know, I'm still not dealing with Sparkplug B, but as far as I know, it's absolutely transparent in point of view of MQTT 3.1, for example, because the whole functionality is into the payload. So any broker doesn't care if there is Sparkplug B or not, right?
Yeah, it's basically.
He's correct.
Sorry?
No, he's correct, right? That the broker doesn't care about the payload.
Yeah, he is correct. Yeah, it's basically just MQTT in MQTT traffic in a certain way in terms of the topic structure and the payload format and so on. But it is a normal MQTT traffic. You don't have to implement all the stuff the Sparkplug specification defines. You can, in your case, you can just have a look at the payload format and implement that, despite of what else is defined in the Sparkplug specification.
Okay, thank you very much for your explanation. I will get myself familiar with Sparkplug B with more details with the documentation. We'll see. Thank you very much, sir.
Thank you, Shweta. Yeah, keep in touch. Keep sharing with us how it's going, and if there's anything we could help with, please keep in touch with us. So I want to pick up this question from Steve Urbanski, and Steve is looking for our comments on the adoption around MQTT 5, and he's also pointing out to the fact that, say, AWS is not even AWS is supporting MQTT 5. Florian, how about I come to you first on adoption, and then why the hyperscalers are not going there yet?
Yeah, absolutely. Happy to take that question, and happy to also report from the field, from out there, right? Because in my position as head of support at HiveMQ, I'm fortunate enough to talk directly to the people that are implementing IoT MQTT use cases in production, and have been doing so for many years now. And I have to say, actually, that now in 2022, which is pretty much probably MQTT 5 has been out now for 26 months, I believe. So a little bit more than 2 years. So very, very young in terms of if you speak of a communications protocol years, that's very young, very fresh. And the adoption that we are seeing is actually increasing a lot. So we see many companies, whenever they get into a state where they build an application themselves that consumes the messages, they tend to go with MQTT5 because, you know, if you look into the ecosystem of client libraries out there, there's many available that use MQTT5. And also, if you look at the ecosystem of MQTT brokers, and I'm talking about MQTT brokers, then also most of them support MQTT5 at this point. I have to agree with Steve that if you look at purely industry, and if you look at machines, PLCs, pre-built devices, pre-built software such as Historian, for example, they typically are not yet there at the use of MQTT5. But from the trends that we are seeing, I have no doubt in my mind that in a few years, MQTT5 will be absolutely dominant for the user properties feature alone. And there's other features that really make it, especially in the IoT world, very useful, such as the topic aliases, just to name one example, a shameless plug for myself. So similar to the Sparkplug essential that Gaurav mentioned, we also have MQTT5 essentials up on the HiveMQ blog with an excellent speaker explaining to you all the MQTT5 features in a 7-part series.
What's his name?
I forgot, but I think he's a support guy.
Yeah.
And coming back to the mention of AWS not supporting MQTT5. So I'm assuming you're referencing to IoT Core. I think it's called AWS IoT Core, which is their somewhat MQTT compliant messaging solution. But if we want to look at that it's also not MQTT 3.1.1 compliant. So AWS, assuming, you know, built this for a very particular purpose, and it's a different purpose to what a pure MQTT broker delivers. And if you're looking at the pure MQTT brokers, they all support MQTT5 these days. And again, many of the hyperscaler solutions are actually not even MQTT 3.1.1 compliant, because, you know, there's some hard to implement stuff there that they'd rather skip and not implement. And that's my take on that. I hope that helped you some way, Steve. Or if you want to jump on the call, we can also have a discussion about it if you have follow-up questions.
So Jeshri, if you could give Steve the right to unmute himself if he wants, and if there's any thoughts they still have. Steve Urbanski, that's the person. Are you able to, Jeshri? Are you able to give them the rights?
Yeah, sorry.
He seems to have some connectivity issues.
Yeah, it looks like Jeshri is having some connectivity challenges here. Okay, we'll keep going, and then we'll come back. We'll come back once Jeshri is back. Okay, I think Steve, you have the option to unmute yourself and ask a follow-up if you like.
Oh, hi, can you hear me?
Yes, we
We can.
Okay, great. No, thanks for taking the question, and you might have received that question before. So this is my first time on one of these chats, so I appreciate you addressing that question. You know, it's something, you know, MQTT5 is something we've been looking into and just monitoring it, trying to decide, you know, if that is something that we should pursue. AWS does provide, you know, frameworks to add MQTT5 capabilities, even though that, you know, they really only support 3.1.1. So, you know, we're just trying to monitor that and figure out what the benefits are for going to MQTT5 and if that's something that we should be pursuing. So just kind of, you know, figuring that out on our side, and just kind of wanted to gauge where the industry was going and how new it was. And if, you know, people are still trying to digest the new standard, or if they're just early adopters right now picking it up. So kind of That's the question.
Yeah, happy to go a little bit more deeply, and thank you for providing the context, right? And it makes sense. But my honest advice to you is, if you have the option, if you're building whatever you're using yourself and you're not reliant on a PLC or a piece of gateway in your system that you don't have control over, there's no downside for going to MQTT5 over MQTT 3.1.1. It's actually improved even the use for constrained devices as well as very powerful devices, and it's definitely the future. And then also, once you implement something with MQTT5, you definitely always have the option to go back to 3 with the implementation that you built around 5, right? But if you choose a solution that's not at 5 yet, you can easily go up, but you can always very easily go back, and professional enterprise MQTT brokers such as HiveMQ, of course, also allow you a way of implementing a heterogeneous ecosystem where you have some MQTT3 clients and some MQTT5 clients, and you can utilize the cool features based on whether your publisher or subscriber is MQTT5 or not. So yeah, I would definitely recommend going with MQTT5 if you have that option. And I'm also very convinced that the industry will adopt it in due time. Again, 2.5 years is still pretty young in the space we're talking about.
Yeah, okay, that's encouraging. Thanks. Thanks for your comments on that, and thanks for taking the question.
Thank you for the question.
And do you rely on AWS? Or so you are basically intend to use AWS services and
yeah, we've used a number before, but we tend to stick with mainstream web services for our products. And so we've used IBM, AWS, and so it looks like AWS, like I said before, it looks like they do provide some guidance on how to use or how to incorporate some MQTT5 capabilities. But we really haven't dug into it in any detail.
As an alternative, you can think about hosting your own MQTT broker supporting all that stuff, and then connect it to the cloud or the hyperscaler you intend to use.
Mm-hmm. So that would be hosting our own broker on like an AWS service.
Yeah.
Yeah.
So,
okay.
For instance, when using the HiveMQ broker, you can make use of extensions. We have a default available extension, which is called Kafka extension. And with help of this extension, you are able to connect, for instance, to the Azure Event Hub services or the event services of AWS. And that's the entry point into the cloud world there, and you have a fully compatible and implemented broker available.
Yeah, that's definitely something to consider. We do have a number of legacy products out there that strictly use 3.1.1. But I'm assuming it would be backwards compatible so that those devices would still work with a MQTT5 broker.
When using HiveMQ, you have the support of both in parallel. You can use MQTT3 and 5 clients in parallel. Because internally in the broker, everything is mapped to MQTT5.
Okay.
And the broker will handle that.
Yeah, right. And I tried to mention this, right? You are even capable of using some of the features that MQTT5 has with your MQTT3 clients when you use HiveMQ as your broker. So just like one example, MQTT3 by default does not support something like a session expiry. But if you're using HiveMQ, where internally we treat everything as MQTT5, you can add a global session expiry that would even apply for MQTT3 clients. So this is just one example showing you if it's possible without violating the protocol towards the MQTT3 client, we are capable of using MQTT5 features even with MQTT3 clients when using HiveMQ as the broker.
Mm-hmm. Okay.
Yeah, the same goes for shared subscriber groups, which is part of MQTT5, but it was also supported by a HiveMQ broker for MQTT 3.1.1.
So Steve, we also did a short webinar on ingesting IoT data into the cloud. And with the cloud, we really are trying to decouple from any one hyperscaler platform. So if you're okay, I could send you a follow-up email with a link to that, and you can see all of this visualized and some walkthroughs on, the 3 or 4 factors you want to keep in mind, or rather can begin to evaluate, right, as you're thinking through what comes next for your evolution here.
Yeah, no, that would be good if you could send that to me. That'd be great.
We will do. Thank you, Steve. Appreciate the question. And thank you, Jens and Florian, for your deep dive here on MQTT5 and all that comes with that. Thank you for that. So I'm going back to the list of questions we have here. And this one is from Sravana Kumar S, who is on the call. So I'm going to read the question from Sravana Kumar. And then if they want to ask a follow-up, we'll give them the opportunity. So they are looking at predictive maintenance. And this question is regards to railway industry. I think that's the domain they are in. Signaling and transportation, judging by the name of the business they registered through. And they're saying, how can IoT systems be used in the predictive maintenance use case? And how, if it can be related to logistics or railway industry? Jens, Florian?
So I can certainly talk about predictive maintenance is one of the more typical use cases that we always line out, and also that some of our key customers are using, and IoT technologies, or with MQTT in particular, comes into play here because it's such a great communication protocol, ingestion protocol, really, right? So MQTT, with all its characteristics, with the way it allows the broker as a single entry point for the connectivity, with being able to handle high latencies or bad connectivity really well, and still ensuring guaranteed message delivery. It's really well built to basically connect anything, even with a bad internet connection, to the broker. And then we get into the conversation that Jens also just alluded to when talking about cloud providers. From the MQTT broker, which is the ingestion of the data, from there you can put it to wherever you have more resources to do your predictive maintenance, right? Because to do predictive maintenance, you need a machine learning model, you need compute resources, ideally a lot of them, right? So this is why predictive maintenance on the edge is sometimes not feasible. But if you use MQTT to get the data into the cloud, then you are into the cloud using technologies like Kafka. Works really well, already mentioned also by Jens, as the intermediate step to get the data from MQTT to Kafka, and then from Kafka you can put it into your whatever machine learning technology you want to be using. And then going one step further, the cool thing about MQTT is it's really bidirectional. So it's an ingestion technology, or it works well as an ingestion technology, yes. But in case of you finding something in your predictive maintenance and you're being like, hey, I don't know, this machine here is 5 degrees Celsius warmer than all the other machines that have produced similar amounts of products. Let's please take it offline to be sure and check. and you can even send this message then back to the machine via MQTT, since it's bidirectional, and basically control the machines as well. And that's so. It's bidirectional characteristics, as well as it's functioning so well as an ingestion layer for all kinds of data into the cloud. That's the reason why I think MQTT is really well suited for any predictive maintenance in general.
Jens?
And in addition to that, if I'm thinking of railway industry, so I assume it's railways, and it's a huge distributed system with all the signaling stuff and sensoring, and maybe also there are sensors on trains. In this kind of environment, MQTT is the solution for that, because Florian already mentioned it. It's built on it's built to be very lightweight and to deal with uncertain connection and so in this kind of environment and ecosystem, it's might be it is one of the best protocols you can use here. So to collect all the data you need. And predictive maintenance basically is based on a huge amount of data to detect anomalies or trends or something. So it's not based on 10 or 1,000 or 100,000 values. We're talking about millions and petabytes of storage, and the kind of time series database for a long period of time, so for 1, 2, 3 years. So you need reliable data ingestion, and you also need to make usage of all the hyperscaling stuff the cloud providers do provide. So huge amount of storage and the certain algorithms to some machine learning or AI to get the results you would like to see, or also to get the results you won't expect, because using the machine learning will also lead into detecting patterns that engineers won't have had in mind. So it's really interesting which kind of results you get to let machine learning algorithm analyze your data.
Thank you, Jens. So Sravana Kumar has one more question. Let me ask that, and then we can give them the opportunity to ask a follow-up. And they are talking about OPC UA and MQTT, which I think is a question we answered a little while back. And then the other question they have is around nominal data carrying capacity or transmission capacity. I assume they're talking about how fast the throughput can be around data analytics. But how about we do this? We'll give Sravan Kumar an opportunity to share with us more, just any context that they can give us. So Sravan Kumar, you have the floor now.
Hi. This is Sravana Kumar.
Hi there. So can you just any more context you can provide around throughput? Yes.
Yeah, since it is saying as a lightweight protocol, when we are transmitting as a payload, is there any restriction in the total number of bytes we are transmitting? Is the question.
You mean the size of the payload?
Yeah.
So according to the specification, you are free to add 65 megabyte of payload per message.
Sorry to be idle here, Jens, but 255 megabytes is the total package size. So that leaves almost that for the payload. But yeah, so
yeah,
very large payloads, very large payloads that are from what we've seen, always larger than what is used.
You can subtract some bytes for the header and so on. So, but yeah, question is if this is really a good way to create such huge messages. Why are you asking? So what do you which message size do you expect in your system?
No, our Indian railway customer, they are asking for what will be the payload message size. So when we are using for this predictive maintenance system, for the maximum number of payload size.
Right.
Yeah. So, like we said, it's close to 255 megabytes for a single payload. Again, the question is, does it really make sense to send such large payloads? Again, when referencing to HiveMQ, to MQTT as a lightweight protocol, it references that the overhead on top of the payload is comparatively low compared to other protocols. Also, we are having the fact of a standing TCP connection, so there's not a handshake necessary every time we send a message. It only happens once, and then we can continuously send messages in a stream without these additional overheads, right? So, and this typically means that the customers decide to go with smaller payload sizes to take advantage of the lightweight of the protocol. Also, MQTT not being designed for large transfers of large payloads, while it's possible, you have to consider that there is no resume capabilities for canceled transmissions. So if you send a 200 megabyte message and after 180 megabytes you lose the connection, you'll have to start fresh. So if you do look to transfer large files via MQTT, what the typical approach is to send a link to an FTP or HTTP file that then can be downloaded with resume capabilities by the receiver of the message.
Okay,
Florian,
thank you.
And Florian, isn't there an element of so with such a large payload, if the connection is disrupted, and then you have a degree of authentication also getting impacted, right? The client would have to then re-register. How does that element work around bringing those devices online? And I'm assuming Shravan Kumar is talking about, he mentioned Indian Railways, which would have, I can imagine, that tens, hundreds of thousands of endpoints, perhaps. So this disconnection of a large payload, and then you are obviously session resumption is a fact. Authentication that has to happen again. Any thoughts?
So you were a little bit chunky there at the end, but I think I got the question. So yes, a client would need to re-authenticate, reauthorize if they lose the connectivity, pretty much regardless of the size of the payload, or if they even were sending up a payload. So looking at the time, I'm not sure if we can go into all of that, because that could fill a whole hour-long session, probably on its own. But so what I can tell you from extensive experience with other customers that have hundreds of thousands, millions, even tens of millions of connected devices that utilize authentication authorization with the client broker approach. It's so you can really authorize and authenticate clients really quickly, and a lot of them simultaneously. Compared to what from a peer-to-peer type of communication approach. I'm not sure if I actually covered your question, but yeah.
No, you did. And Florian, again, I think time is a factor here. So in fact, perhaps a good opportunity for us to mention that May 25th is when we are doing a webinar on IoT security basics, which is where we'll cover this in much better detail. And Florian, hopefully you'll be able to join me also, so we can answer some real life scenarios. So Sravan Kumar and anybody else who's on here, please do join us for that, and we'll be able to talk about not just the issues we covered today, but also at scale how the security element comes into play, and at IoT scale how other such complications need to be factored in. Jens, you have any thoughts? Yeah.
Yeah, I just had would like to mention in terms of the large messages. For sure, you have a kind of delivery service. So we have in MQTT, you have the quality of service 1 and 2, which grants kind of delivery. But in terms of large messages and large payloads, when for instance, the client loses the broker connection and all these messages are stored in a session, as long as the client does not reconnect and does receive the messages are stored on a broker. And this might lead very quickly into memory problems or storage issues.
Thank you, Jens. So that's the end of the questions which were submitted to us, and I don't think there's any other pending questions here in the Q&A part. Jayashree, can you just confirm there's nothing else that we haven't been able to get to?
No, I think we have
All
covered everything. I'll
Excellent.
quickly run the second polls if that's fine.
Please go ahead.
Cool. Request all attendees to participate. If you have any further questions, please reach out to us. We are here to help. If you need any links to resources, just email me. I can help you out. So before we close the session, any thoughts? Gaurav, Jens, Florian?
I'm good. I'm glad there was some really interesting questions, very broad conversations. Florian, Jens, any final thoughts from you?
Yes, I during the last sessions and also during the last conferences I attended, I really see a strong demand on or interest on Sparkplug, but also in how to deal with the current OPC UA infrastructures and architectures, and how to do the next step in a more digitalization, or the next step in digitalization in terms of industrial IoT. So that's really interesting for me that the demand on this is really increasing, especially in Americas or outside of Germany, because I still got the impression that the German industry is so proud about its automation, grade of automation, that they should not miss to do the necessary next steps.
Great, thank you for sharing.
Yeah, and you know me, Gaurav, I'm the MQTT5 guy. I always advocate for MQTT5. So having someone like Steve come in here and ask about it fills my heart with joy, because I can only tell everybody you should really move to MQTT5 if you have the opportunity. The feature set might seem not as severe, but if you really look into it, it can save you money. So absolutely. Go for it.
Yeah. Very cool. Thank you so much. Back to you, Jayashree.
I think we have covered everything. Thank you so much for participating in the polls. We will see you next time, and also to register for our next webinar, which is on May 25th. It's on IoT security. So, yep. See you all next time.
See you there.
Thank you so much.
Thanks, everybody.
Okay.
Thanks, Gaurav.
Bye-bye.
Thanks, Jens.
Thank you,
Thanks, Florian. See you. Bye-bye.
Bye-bye.